My name is Dale Vancore, and I have created a new use for recycled plastic. It is called a keyed brick. This keyed brick has 4 types of interlocking connections that fasten in a single twist. I'll let the rest of the video show you. This is a 3D printed keyed brick. These connecting structures are called key threads. It has raised keys and recessed locks. Connecting these keys with their locks is done by rotating them into each other. They start loose, and then all the surfaces come together at the same time. This strong connection is difficult to separate. Individual key threads are grouped into sets. The 2 sets raised out of the top are the keys. The 2 sets recessed into the bottom are the locks. The open curved end has raised keys. The closed curved end has recessed locks. Now each set is a unit that engages with a different part. Collectively, their shape and orientation create unit characteristics. These 2 sets are angled towards their center. When assembled, they clamp 2 other bricks together. Now we're going to demonstrate how to assemble the keyed bricks. We're going to start, we already have one existing wall. I'm going to add 1 brick here. Now this is our reference brick. We're going to start this, and what I want to show you is that it has 3 threads, 1 here and 2 here, that all have the same axis of rotation. So I'm going to take it back off. It doesn't come out straight. All right, now we'll put it back in. All 3 threads engage at the same time. Okay, now we're going to add a 3rd brick to the other end of our reference brick. Now, what this is to demonstrate is this brick is now locked in place because it has this axis of rotation, but the thread on this one has its own axis of rotation up here. So this can't move with 2 axes, even though the bricks were relatively loose. Now we go put a 3rd one on this middle reference. We now have this subject to 3 different axes to hold it in place. And this completes it. The reference brick is now thoroughly locked in place because there are 4 different axes of rotation on these threads that hold it. I will take this from a different angle. I'm going to demonstrate the assembly from a side view. We're going to put this thread in place first. Now we're going to take our reference block and rotate this into position. So this engages 3 threads. Now I'm going to put this block on the other side of the reference block. Now that reference block is now engaged in 4 threads. So that will prevent the movement. Now if we take 2 others, just to lock up this top thread, thoroughly lock it up. We now have this brick at its full multi-axial locking. It is stronger than the ones that we just put on, because this only had one axis. This one has two. All right, let's take this apart now. They have to come apart in the order they were assembled. Can't take this one off because that's not its axis of rotation. Now I can. These bricks are hollow, and as you can see, they're fairly thin-walled. Now I'm going to set my set of key threads down here just to show you how strong they are. I'm going to stand on them. The point to this is that keyed bricks will hold laterally. They are actually more spherical in their resistance, and like all walls, hold vertically. These are strong connections. These bricks are scalable. That means the same design can be made at different sizes with different materials. This toy can be scaled to the size of a brick or more. They can also be made for circular or spherical applications and still twist into position. The world produces over 300 million tons of plastic annually. Most of it eventually ends up in landfills. The keyed brick can turn some of that waste into something that people can use. There are more details at keyedbrick.com. Thank you.